Hey, welcome back, everybody. So, this is the beginning of our polynomials unit. This first lesson has kind of a lot of definitions and stuff that we got to go through so we can be speaking the same language as we go through this unit. First of all, a monomial, a number of variable or product of number and one or more variables. So basically, it's anything that we use in math. So when I say, basically it's a like term. Anything that can be considered a like term, so that's a monomial. This is a monomial. 5x to the fifth y is a monomial. Anything that could be considered a like or unlike term is a monomial. A polynomial is just when you have one or more monomials added together or subtracted, which is really adding a negative. The degree of the polynomial, this is important and would be really important in pre-calc, is the degree of the term with the greatest exponent. So if there's only one variable, you look for the highest exponent, that's the degree of the polynomial. And in standard form, we write the degrees of, we write the terms all in descending order of degree, so highest degree to lowest degree. So this is the generic form of standard form of a polynomial. Each term is referred to by its degree. So this is considered the constant term because it's a constant. There is no variation. There's no variable. Linear term, quadratic term, cubic term. And then after that, you basically just say fourth degree, fifth degree, whatever degree term. So highest exponent down to lowest exponent. All right. So monomial, you can classify them by how many terms there are. A monomial just has one term. A binomial, you've seen, has two terms. You factor something, you usually get a couple binomials. And a trinomial is what we factor. It has three terms. So a few examples here. I'm going to kind of go through these quickly. Just a number, that'd be a degree 0. We call it a constant. Number of terms is 1, so we call it a monomial. This is a degree 1, even though there's nothing written there. You see that really the degree is a 1. So that is a linear polynomial, or linear binomial, we would say, because it's only got 2. So this next one's a trinomial of degree 2, so it's a quadratic trinomial. This one has degree 3, 2 terms, so that's going to be a cubic binomial. 1 term. Quartic is technically something we could use, or you could just call it degree 4. Monomial. That's a trinomial. Anything higher than degree 4, you just call it degree, whatever its degree is. All right. So I'm expecting you to have these problems written and completed when I check the stuff next class. All right. Screenshot that or whatever. Here we go. Next topic. Here we go. End behavior. So now we're talking about what happens way out on the graph. Not locally, but if I were to increase x towards infinity or towards negative infinity, what's the behavior of the graph? Basically, it's just going to be up or down. So let's look at x squared. If we graph an x squared, as we go right on the graph, as x is going this way, what is happening with the graph? It's going up. So we say that to the far right, it's goes up, and as x is going this way, to the left, the graph is going up. So its end behavior is tends towards infinity. The y is going towards infinity as we move right, and as we move left, the y is going towards infinity. Looking at the negative x squared graph. As we move right, it's tending down towards negative infinity. The farther right we go, the farther down it goes. Similarly, the farther left we go, farther down it goes. So to the left, it tends towards negative infinity. If we graph these, you could grab your graphing calculator, or I graphed them here. You'll notice that as x increases, y increases. As x decreases, y decreases. So we say that it's tending towards positive infinity as we increase the x, and towards negative infinity as we decrease the x. Or also we say sometimes as x is large, y tends towards infinity. As x is less or greatly negative, it tends towards negative infinity. basically thinking about what's going to happen if you get a really big positive or negative x value. Really big negative x value here, it's going to be a really big positive y value. Go towards infinity on the x in the positive direction, goes towards negative infinity on the x in the y direction. All right, now notice these. This is going to tend towards infinity and negative infinity. Notice that both of these have an even degree. Anytime the degree is even, they're going to either both tend up or both tend down. So just by looking at this first term, we can see what's going to happen at the overall behavior. If we were to zoom way out, what's going on with the graph. So with this one, the A is positive. This is positive, which means it's going to open up, and then it's an even degree, so it's going to go up both in the positive and in the negative direction. This one over here, oops, my bad. This one over here is a negative A. The number in front is negative, so it's going to open down, and then it's an even degree, so they're both going to tend towards negative infinity, either to the left or to the right. Odd functions are so named because the degree is odd. If the degree is odd, you're going to have one end going up, one end going down. When it's a positive coefficient in the leading term, then it's going to go up as we go to the right and tend towards negative infinity as we go to the left. A negative flips that function, basically, and goes towards infinity to the left, and to the right tends towards negative infinity. So there's a little summary of that. I would jot that down, positive you got to. And then here's your U-try for that. Sorry this video is so long. I'll make it up to you next time.